Hello, hi. So today we are going to solve this problem called it's from Leetcode April challenge from today's challenge, April 8th. So it's the kth largest element in a stream, and the problem asks us to design a class to find the kth largest element in a stream. And kth largest element is in the sorted order, not just the kth distinct element, which means like if you have, let's say, uh, three values, three fours, then the third one, yeah, basically the equal values are counted, the duplicate values are counted. And we want to implement the kth largest class. We have an initializer, we get k, which is this value, and when we need to have a function add that adds a value and returns the element representing the kth largest element. This is a little bit odd. Add usually should return true or false if the value was added, or just not return anything. But yeah, let's implement it anyway. Okay, so we need to have an initializer, and then so we have a k here, so we can just say equal to this, so that we can have these. And now here we need to implement the add function. So first we need to add the element, and then we need to get the now since we want the kth largest element, I think it will be wiser to just use a priority queue here so that we can easily obtain it. So instead of doing this, let's just have our priority queue and let's heapify this. So that would be, so we want the kth largest, right? And what I'm going to use is heap queue in Python. And so we can use a heap queue, which is a min priority queue. Now, how can we get the kth largest element? So we have, I think we have n largest here. So returns a list with the n largest element in the data sets. So we can just get the k largest elements and then take the last one, right? So we could just do that. And so here we could just heapify using the list that we get. So that would be heapify, just calling heapify here. And then after that we will need to add here. So we need to add, I think they mean returning the kth after adding, so that would be heap queue here. We need to push, so heap push this and then push the value. So that's the first step. After that we need to just do heap queue n largest, and then we need to pass n and then the iterable. So n value is self dot. So first we need to pass n, which is k in our case here, so self.k, and then we pass the heap, and now we can have, and then we need to return the last one, right? So that would be -1, and then we can just return this. So this is heap q. Heap push. I think this should work. Heap q, right? Must be a list. Well, that's what we are passing here. Oh, it must be a list. Okay, maybe I did something wrong here. So I'm calling heapify heapq.heapify x. Oh yeah, so what heapify does is actually it modifies the parameter. It doesn't return a value, so it transforms the parameter in place. So what I need to do here is have self.priority queue is equal to nums, right? And then heapify that. And it seems like that works. Let's try more examples. Okay, maybe we can. Yeah, I think this should work. So let's just submit. It's taking a little bit of time. So in the meantime, maybe we can. Oh, time limit exceeded. So it seems like this is not the fastest. Yeah, actually the thing is we don't need to put the entire list of values in the heap, because then it would be really, we can just maintain k element. We only need to maintain k elements, right? Because the goal of this data structure is just to return the kth largest, so we don't need to maintain the entire list. So how can we do that? So here we could just do while length of, so we push. So we only have add, so here we can do if length of that priority queue is bigger than k. Okay, we can do while here. Maybe we should here do pop. And then at the end, we could just return. Do we have a way to return the head or something? I think that would be just the last element, right? Yeah, it's okay. This is definitely not it. It maintained the. So we keep adding, and the next time that we have more than k, we pop the smallest element. Does that make sense? I don't think it makes sense. Okay, let's think about this a little bit more. So anything larger than k, larger than kth, can be removed. So once we add here, when we pop, we'll pop the smallest element, not the largest. So I think one thing I should do maybe is make this like this for x in nums. Now I have it in the reverse order, and I will push minus val. And now here, if I do while the length is bigger than k, then what I want is to pop largest. Okay, that makes sense though, actually. We want to pop smallest. And pop will, if we look at heap, pop and return the smallest item. So it will pop the smallest item. So what I want is actually what was here. I want to pop oh, did I use that pop instead? If I did, then that was the problem. Let's see. Yeah, that was the problem. I didn't use the pop function of heap queue. My bad. And then here we need to return the largest, which is sorry, we need to return the we are guaranteeing that it has k element, and since it's the smallest, we need to return the last element since it's in sorted order. Okay, something seems weird here. Let me take a smaller version. So maybe we could just have this, and we have the initial array, and then we have add 3. Okay, so let's see. So the output is okay. This is weird. So let's print. In our case here, let's print val equal to val, and then let's print maybe also here. So and maybe this is 1, this is 2, and then we could have something like just the priority queue itself each time, so we can see what is happening. Okay, so we are adding 3, and then we add 3 here, so we have 2, 3, 8, 5, 4, which means we have more than k, which is 3, more than k elements, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5, and so we want to remove the largest, and so we want to remove the smallest, so we remove 2, and then we want to get the largest, the third largest. So that it should be technically 8, 5, 4, right? So it should be. So here, print, maybe let's print this 3 self.pq. So here 4, 5, 8. So the last one is 8, which is not what we should do. We should return 0. That's the largest. We maintain k elements, so the largest one is in the first position. Okay, so that seems to work. Now let's try to have, or let's try to submit actually. Just comment this out first. Okay. Okay, so that passes. Cool. Okay, so now let's see if there is another solution, maybe. Okay, before that, actually, I think we can solve it differently. Instead of using a heap queue, I think we can use we should be able to use bisect insert, which inserts in a specific position in a sorted order. So maybe we could do this, right, instead, and then sort. And now with that we can here just do a similar thing. Actually, let me put this back so we could do this, but instead of doing heap queue.push, we can do insert and insert a value, and then from there what we can do is here, if it's bigger than k, we need to pop the, so before what we used to do is remove the smallest element. Here I'm not sure if we should remove the smallest element, or how do we remove the smallest element. Could definitely do self.pq dot, I think pop -1 should work. Let me try it out. So if I have, let's say, this array, right, a is equal to that, and then do sort. So a is like this. Now what if I do bisect, import bisect of course, and then bisect insert a, maybe let's add 3. So now a has it in the sorted order. Now if I do a dot pop and then pass the index, so it pops the largest element. That's not what I want. I wanted to pop the smallest element. So if I do pop, just pop, it will still pop the largest element, but this pops the smallest. Okay, so we need 0. And then we need to pass the last one. And that should be it. Okay, so it's not, I'm using nums now, so I need to pass that instead. Okay, let's submit. Okay, that passes test cases.